Hello and welcome back. Today we'll be doing a question about frustrums made of water. So let's get started. Firstly, I'll give you two frustrums. One is wider at the top and one is wider at the bottom. They are the exact same dimensions, however, one has simply been turned upside down. Both frustrums are filled with water and they both have a hole drilled at the bottom. Which one empties first? If you chose the left-hand one, then you would be correct. This is because the greater height causes a greater outflow rate of water, and this greater outflow rate, coupled with the greater volume, overall decreases the time. However, this got me thinking, how does water actually flow out of a frustrum like this? So I set up the following system below. Here I set up a system where the top radius was r1 and the bottom radius was r0. The height of the water was h and the radius of the frustrum at that height was r. The total height was h and the hole at the bottom had an area of a. Firstly, we'll quote Torricelli's law to get that the outflow rate is V is equal to the square root of 2gh, and therefore the outflow rate, which is volume per time, is equal to negative A multiplied by 2gh. I'll also find the top surface area of the water at height h, and this is simply pi r squared, which is equal to pi of r0 plus h over big H of delta r, all squared. And therefore, by conservation of volume, we have that the outflow rate on the left and the rate of change of height multiplied by the height on the right are equal. From here, we can simply rearrange to get t on one side and h on the other, and then we can integrate on both sides, giving us a root of 2g all over pi multiplied by t is equal to the integral between h and big H of r0 plus u of delta r over big H, all squared, all over the square root of u du. Notice here that u is a dummy variable corresponding to small h. We have used u as a dummy variable so that we are not confused between the limit h and the variable h. From here, we can simply expand the numerator, then integrate, and then we can substitute the limits little h and big H, and then we can equate this to the left-hand side. We can then divide across a root 2g all over pi, and also collect up the root h terms to get this final result. And this result should model how water flows out of a frustrum. Here is that graph drawn by Desmos. Initially, the rate of flow is quite high due to the large pressure, although it slows down a bit due to the pressure decreasing. At the bottom, the pressure is very low, so the rate of flow decreases very sharply. We'll notice that the line is basically fairly straight at the top, since the radius is also decreasing, and that naturally increases the rate of flow. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.